Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, I want us to talk about pure mathematics for coordinate geometry. That is chapter 3 of this book, Pure Mathematics for International and Excel level, international at the Excel International level, IAL, International Advanced level. And we have been talking about parametric curves, and I want us to just discuss something to do with example 6, which is on page 25. And sketching curves is not a new topic, but I know this one is a different one because it does not directly involve x and y as we know it. It has parametric variables. And as we are told on page 25 and under 3.3, most parametric curves do not result in curves you will recognize and curves you can easily sketch. You may not really come up with quadratic curves, cubic curves, which are quite popular with us so far. You will find curves that are a bit unique. But of course, what is advisable in this is that anytime you are doing tabulation, or you are making a table of values, ensure that you have as many intervals of x as possible so that you can acquire a shape a graph that will direct you to whatever it is that you may want to acquire as a graph. The key thing is have as many intervals of x along the x-axis as possible. So example 6 says draw the curve given by parametric equations. X is equals to 3 cos t plus 4 and y is equals to 2 sin t, and this t is greater than or equals to 0 all the way to 2 pi. Remember, these are radians. When we are talking of radians, it is important to have the table of values throughout so that we can sketch these curves comfortably. And therefore, we must have now the value of t, or the row of t, the row of x, which is equals to 3 cosine t plus 4, and we have y, because at the end of the day, we are going to have a graph that is in xy Cartesian plane. So the variables will obviously be x and y, or y against x. So y is equals to 2 sine t. And at that point, we can make our table of values. Remember, one secret we have identified is that have as many intervals of x as possible. So let's talk about t being 0, because 0 is the lower limit and it is inclusive, you can see. What is the value of x? 3 cosine 0 plus 4. 3 times cosine 0 plus 4. What is that? 7. You get 7. What about the value of y? The value of y becomes 2 sine t. 2 sine 0, and of course close bracket, and you have 0, and you have 0. That is the first set of values. So at the end of the day, you have as many intervals, regular intervals of x as possible, as many as possible. Let's have as many as possible. We can probably have pi over 4, pi over 2. We can have an interval quarter after every quarter pi. So half pi, 1.5. That is pi over 2 plus a quarter, 3/4 pi. Then we have pi. Then we have 1.25 pi, which is 5 pi over 4. 1 plus 1.25 is 1.5, 3 pi over 2. And then 1.5, 1 3/4, which is 7 pi over 4. 7 pi over 4 plus a quarter, probably now you get to 2 pi. And I hope those are just enough intervals. So our work here is just to play around with the calculator, and as you feel now, 3, the value of x when t is pi over 4, 3 cos pi divided by 4, close bracket, plus 4, you will find this is 6.12. 6.12. And the same thing, the value of y when this is now, when t is pi over 4, 2 sine t, 2 sine pi over 4, close bracket, is equals to root 2, which is 1.41. 1.41. You will do this way throughout until when t is pi over 2, x will be 4 and y will be 2. When pi will be 3/4 pi, when t will be 3/4 pi, x will be 1.88, y will be 1.41. X will be pi, when t will be pi, x will be 1, y will be 0. When t will be 5 pi over 4, this will be 1.88. This is negative 1.41. The 1.5 pi, x will be 4, and this will be minus 2. 7 pi over 4, 6.12 will be the value of x, minus 1.41. 2 pi, 7, and 0. And I mean, you just have to confirm that these are the values you'll be getting after you substitute pi throughout. So you are left with now the duty or responsibility of plotting that curve. You can see the value of x is all positive, so the highest value of y is 2 and negative 2, so 1, 2. This is negative 1, negative 2. What about the value of x? The value of x is ranging from 0 all the way to, let's say, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6, 7. So when t is 0, x is 7 and y is 0. When t is pi over 4, x is 6.12, and y is 1.88, somewhere there. When t is pi over 2, x is 4, y is 2. You can see, so something like that. And then when t is 3 pi over 4, x is 1.88, somewhere here. Yes, 1.88. And the value of y is 1.41, around there. When we have pi being equals to t being equals to pi, x is 1, yes, and y is 0, somewhere there. And the same values are repeated, but now on the negative side of y. So 5 pi over 4, 1.88 negative 1.44, somewhere there. When 4 minus 2, 4 minus 2, and then 6.12 minus 1.4, and 7, 0, we go back there. So at the end of the day, you are likely to get a curve that looks like that. It is not a circle. If you use now graph paper, you should be coming up with a very, very good curve. Otherwise, even this one should have been that way. That way. This one is the curve that we expect. That is the curve that we expect. Yes, it's true that if you use a graph paper, you will get a very, very beautiful curve. This is y-axis and this is x-axis. So let's just trust that we shall be able to get there easily. All right. Yes, that's just the curve. If you read the yellow pages, this parametric curve has Cartesian equation x minus 4 over 3 plus y. We verify this. It has Cartesian equation x minus 4 over 3 squared plus y over 2 squared is equals to 1. Let's just verify this after we make y the subject of the formula. But anyway, this is not important for now because it's not asked in this question, but it's just good to know. All right.